Let's work on the problem 8.10 part B. Transfer function g of s is given as this, and we need to sketch root locus diagram. First thing we want to do, we want to find zeros and poles. For zeros, if you use your calculator, then we're going to have a 1 plus minus j. And for poles, for the denominator, we have 0, -1, and -2. So if we sketch this, we have 1, this is j, this is -j. Zeros are 1 plus j right here, 1 minus j right here. And the poles, we have a 0, -1, and -2. Let's find the real axis intercept the asymptote angles. Then sigma A equals sum of poles minus sum of zeros over number of poles minus number of zeros. Then sum of poles -1, -2 minus sum of zeros 1 plus j plus 1 minus j. And number of poles 3 minus number of zeros, 2. So that will give us -5. Now the theta A is going to be 2k plus 1 pi over number of poles minus number of zeros. That is 2k plus 1 pi. If k equals to 0, that'll give us pi, and k equals to 1, that is 3 pi, which is pi, so there's only 1. Now, break in, break out, or break in, break away points. We have transfer function g of s as k s squared minus 2s plus 2 over, we have a s squared plus s times s plus 2. Now we're going to let this equals to 1 and find the value of k. Now at the same time, you're going to change s to sigma. That is the real axis, break in, break out. Then sigma cube plus 3 sigma square plus 2 sigma. We have a sigma square minus 2 sigma plus 2. Now we do dk over this sigma, then negative derivative of numerator 3 sigma square plus 6 sigma plus 2 times denominator minus numerator 3 sigma square plus 2 sigma, and derivative of denominator 2 sigma minus 2, everything over denominator square. That's the quotient rule, and we need to find this equals to 0. The values of this guy was 0, so we can just take this portion and equals to 0. Then we have, I'm gonna do this guy distributed and so on. 0 equals just the numerator terms. We're gonna multiply all of those. Then
we have a 3 sigma 4 plus 6 sigma 3 plus 2 sigma squared, and then minus 2 sigma times those three terms, 6 sigma cubed minus 12 sigma squared minus 4 sigma, and then 2 times those three terms plus 6 sigma squared plus 12 sigma plus 4. And then second one is a negative. So we have a negative 2 sigma 4 minus 6 sigma cubed minus 4 sigma squared, and then plus 2 sigma cubed plus 6 sigma squared plus 4 sigma.
Then 0 equals the fourth terms, these two, we have a sigma 4, and then cubic terms, this 6 positive 6 negative 6 out, we have a -6 and then +2. Therefore, we have a -4 sigma cube. And then square term, we have a square 2, 12, +6 will cancel with the -12, -4, -2 sigma squared. Sigma terms, plus -4, plus 6, +4. So we have +12 sigma and then +4. Now, if you plug the coefficient in your calculator, then the sigma values are 0.33, negative 1.5, 2.33, and 3.5. And negative 0.33, where is a negative 0.33? Negative 0.33 is somewhere in here. And then we have a negative 1.5, 2.33 somewhere here, and then 3.5 is somewhere here. Next, now we want to find j omega axis crossing, right? G of s is given as ks squared minus 2s plus 2 s cubed plus 3s squared plus 2s. This is the transfer function with unity feedback. Now we need to take care of the unity feedback so that we can have the t of s. That is, numerator is the same, ks squared minus 2ks plus 2k. And the denominator, we have s cubed plus 3s squared plus 2s plus ks squared minus 2ks plus 2k. As we said, if you take care of the unity feedback, you just simply need to add the numerator to the denominator. That's all we need to do. You don't have to use feedback formula. If you want to, you can do that as well. For just the denominator, it's gonna be s cubed plus 3 plus ks squared plus 2 minus 2ks plus 2k. Based on what we learned from chapter 6, the root table, we can have s cubed terms as 1 and 2 minus 2k, and s squared term as a 3 plus k and 2k, and then s1 is going to be negative 1, 3 plus k, 2 minus 2k, and 2k, divided by 3 plus k, and 0. That equals negative AD 2k minus BC. If you multiply that, 3 times 2, 6, and then we have remember we have a negative, so negative 6 plus 6k minus 2k plus 2k squared over 3 plus k, and that is negative 2k squared plus 6k minus 6 over 3 plus k. This is the row of 0 k's, and finally s0 term is gonna be here 2k. This is not row of 0. We cannot use that because the oxy equation will not give us j omega axis. Now, since this is the row of 0, the oxy equation is gonna be 3 plus ks squared plus 2k equals to 0. Now we need to find the value of 0. In order to make this as a row of 0, we have 2k squared plus 6k minus 6 equals to 0. From here, we have a k equals negative 3.79 and k equals 0.79. These two values will both give us imaginary number. However, as we said, k has to be greater than 0 in order to be stable on this transfer function. So the stability condition is going to be 0k 0.79. So we cannot use this k value. Now, if you use k equals to 0.7, plug in this oxy equation, we have 3.79 s squared equals negative 1.58. And from here, s equals to plus minus j 0.65. Go back here, plus minus 0.65. So it's 0.65 somewhere. J 0.65, negative j 0.65. Now, so for the break-in breakout points that we calculate, this cannot be. So now let's plot the root locus. So we said root locus exists to the left of an odd number of real axis poles and zeros. This is the first pole, and that's the odds. Therefore, it's gonna be this side. This is the third one, so it should be this. Based on what we have in the root locus, we have to use the break-in breakout point as this negative 0.33. Therefore, we are not going to use these points. Then break out to here. That's the j omega axis crossing. And then j omega axis crossing there. So this is our complete root locus diagram.